Hello, good morning, students. Good morning.
Good morning, sir.
Am I audible?
Yes, sir.
Okay. We'll start the session. As soon as you enter, please enter your name and USN in the chat box. Okay. Okay. In the previous class, we discussed about vapor compression refrigeration system. Okay. In the previous class, we discussed about vapor compression refrigeration system. In the vapor compression refrigeration system, mainly we are having four parts you studied in the previous class. One is evaporator, compressor, condenser, and expansion valve. Okay. Today, I'll discuss another important refrigeration system that is called as vapor absorption refrigeration system. Okay, in the vapor compression refrigeration system, a carrier substance called as refrigerant is used. So we are using a vapor absorption refrigeration system. So in case of vapor compression refrigeration system, so we are having using only one refrigerant. But in case of vapor absorption refrigeration system, there are two substances used. One is refrigerant and another one is absorbent. Okay. So the refrigerant which is soluble in other substance, that is called as absorbent. So in case of VCR, refrigerant like ammonia, sulfur dioxide, freon group of refrigerants are used. Whereas in case of VAR, the refrigerant as well as absorbents are used in the VAR. Okay. So what are the examples? Your refrigerant is ammonia, which is easily soluble in water. That is called as the absorbent. Another example is water is used as a refrigerant and lithium bromide is used as absorbent. So in case of VAR, vapor absorption refrigeration cycle, two components, one is refrigerant and another one is absorbent is used. the refrigerant is water and absorbent is lithium bromide, or refrigerant is ammonia and absorbent is water. Like that, we are going to use the combination. Okay, then next comes construction of your VAR. What are the main components of your VAR? So as you studied, in case of VCR, we are having four parts. One is evaporator, second one is condenser, third one is compressor, and fourth one is your expansion valve. Okay, you observe this diagram. So we are not having compressor. So the compressor does not exist in case of VAR. So that compressor part is replaced by the three parts. One is absorber, second one is heat exchanger, and third one is generator. We don't have compressor in case of VAR. Rather, we are having the three parts called as absorber, heat exchanger, and generator. And we are having absorbent and refrigerant in case of VCR. Okay, so we are having the parts of vapor absorption refrigeration system as first one is evaporator, second one is absorber, third one is pump, fourth one is heat exchanger, fifth one is generator with heating coil. Next, we are having the condenser and expansion valve. Remember that compressor in case of VCR is replaced by this unit, that is generator with heating coil, heat exchanger, and absorber. So this is the replacement in case of VAR. Refrigerant and absorbents are used in case of vapor absorption refrigeration system. Why the name absorption? Means we are having a part called as absorber. Vapor compression means we are having compressor in VCR. We are having absorber in case of VAR. Okay, so these are the parts. So I'll repeat once again. So it consisting of evaporator, absorber, heat exchanger, generator, condenser, expansion valve, and evaporator. Now I'll explain the working principle of this vapor absorption refrigeration system, how VAR works. Okay, now starting, we are going to take, always you remember, we are going to take with low pressure and low temperature liquid ammonia. As I said, the ammonia is used as a refrigerant and water as absorbent in case of VAR. That is, one is refrigerant and one is absorbent. Low pressure, low temperature liquid ammonia enters into the evaporator. As I said, the main function of evaporator is to convert the liquid phase into vapor phase. When low pressure, low temperature liquid ammonia enters into the evaporator, it absorbs the heat from the cabinet. As I said, this evaporator is placed inside the cabinet in the refrigeration system. When this low pressure, low temperature liquid ammonia enters into the evaporator, it absorbs the heat from the cabinet and thereby changing the phase from liquid to vapor. Okay, the function of evaporator is to convert the liquid to vapor phase. When low pressure, low temperature liquid ammonia enters into the evaporator, it absorbs the heat from the cabinet, thereby changing the phase from liquid to vapor. Now, what is the condition of refrigerant after passing through the evaporator? Means low pressure and low temperature ammonia vapor. So there is no change in condition, that is the pressure and temperature remains same, only the change in phase, that is liquid ammonia is converted into vapor ammonia after passing through the evaporator. So this is how the change of phase takes place in the evaporator. That is, we are having low pressure, low temperature ammonia vapor after passing through the evaporator. That low pressure, low temperature ammonia vapor so which enters into the absorber. You remember, so this absorber consisting of mixture of ammonia and water, which is weak at the beginning. We are having the ammonia and water inside the absorber, and which is weak in nature. When this low pressure, low temperature ammonia vapor enters into the absorber, the ammonia becomes strong. Okay, remember here we are having the weak solution initially. When the low pressure, low temperature ammonia vapor enters into the absorber, so that the weak ammonia solution becomes the strong solution. Remember, when it enters into the absorber, it becomes strong solution. Okay. Next, what is the condition of ammonia after passing through the absorber? So, low pressure, low temperature, strong ammonia solution. Here, low pressure, low temperature, weak ammonia solution, which is in vapor form only. So, when it enters into the absorber, which consisting of mixture of ammonia and water, so that the ammonia vapor becomes strong. So we need strong solution for the next cycle of operation. For that purpose, we are going to pass through the absorber, so that when it enters into the absorber, the weak ammonia solution becomes strong ammonia solution. Now there is no change in pressure and temperature. That is low pressure and low temperature only. So after passing through the absorber, ammonia becomes strong. So we'll get low pressure and low temperature ammonia solution. So this is how the ammonia vapor passes through the absorber. The next function is this low pressure, the low temperature, strong ammonia solution then taken into the pump. You remember, we are having compressor in case of vapor compression refrigeration system or VCR. That part is replaced by pump in case of VAR. You remember, we are having pump. The main function of the pump, already studied the function of pump in centrifugal pump, means to lift the water from lower level to a higher level. Means the main function is to increase the pressure. So when there is an increase in the pressure, easily it can lift from lower level to higher level. So the main function of the pump is to lift at the higher pressure. What is the condition now? Low pressure, low temperature, strong ammonia solution is passes through the pump, and this enters into the heat exchanger. Okay, we are having a part called as heat exchanger. Heat exchanger means it is a device where the exchange of heat takes place. For example, your boiler, you studied in fire tube boiler and one more water tube boiler, where exchange of the heat takes place. Means in one pipe water is flowing, in another pipe steam is flowing. That is also a sort of heat exchanger. Heat exchanger is a device where the exchange of heat takes place between one fluid and another fluid. For example, it is cold fluid, it is hot fluid, then hot fluid gives away the heat to cold fluid, whereas this cold fluid gets the heat from hot fluid. That's why it is called as heat exchanger. It is cold fluid and it is hot fluid. So that it exchanges the heat, means it takes the heat from the hot fluid, thereby becoming hot. Okay. Now this low pressure strong ammonia solution from the absorber enters into the heat exchanger. So when it enters into the heat exchanger, this ammonia solution becomes hot because it exchanges the heat with the hot fluid. So this is the cold fluid. So this cold fluid gets the heat from the hot fluid. Okay, this exchanges the heat from hot fluid, thereby it becomes the fluid as hot. Now, what is the condition of ammonia after passing through the heat exchanger? Means here we are having low pressure, low temperature strong ammonia solution. So after passing through the heat exchanger, the temperature increases. So that as I said, the main function of the pump is to increase the pressure. So we'll get, instead of low pressure, we are getting high pressure. Here, instead of getting low temperature, we are getting high temperature, and we are having strong ammonia solution. When it becomes strong, after passing through the absorber. So we'll get the condition as high pressure and high temperature strong ammonia solution after passing through the heat exchanger. So one more is there, as the hot fluid gives away the heat to the cold fluid, then that remaining enters into the absorber. There is a continuous flow of weak solution and strong solution in this circuit. Okay, so as soon as it takes the heat from the hot fluid, that weak solution, it becomes weak, then that enters into the absorber. Now this high pressure and high temperature ammonia solution then enters into the generator. It is like means boiler only, means we are going to supply the heat externally with the help of LPG gas or whatever it is, so that heat is supplied externally. You might observe here we are having a heating coil. When the high pressure and high temperature strong ammonia solution enters into the generator, the heat is supplied externally. When it is heated, that we are having ammonia vapor that floats on the surface of the cabinet, and remaining liquid is there, no, that leaves at the bottom portion. As I said, the density of vapor is always lesser than your density of the liquid. That's why it floats on the surface of the cabinet. So when the high pressure and high temperature strong ammonia solution enters into the generator, the heat is supplied externally. Because of the heat supplied, the ammonia vapor gets floating on the surface, and remaining that water is there, it leaves at the bottom. That weak ammonia solution only circulates into the absorber, and it mixes with the low pressure, thereby becoming the strong. So when it enters into the generator, the vapor floats on the surface, and remaining that liquid phase is there, no, that liquid phase enters into the absorber, and this ammonia vapor floats on the surface. Okay, now there is no change in the temperature and pressure, because we'll get high temperature and high pressure the ammonia vapor. Okay, we are not calling it as solution, this is vapor. And here in this circuit we are calling it as solution, here also solution, and here we are calling it as just vapor. So, and there is no change in pressure and temperature. So high pressure, high temperature ammonia vapor from the generator enters into the condenser. As I said in the previous class, condenser is similar to your evaporator. Okay, here in the evaporator there is change in phase from liquid to vapor, whereas in case of condenser there is a change in phase from vapor to liquid, means it gives away the heat to the surroundings. That is called condensation. Evaporation means the change in phase from liquid to vapor. Condensation means from vapor to liquid. When this high pressure, high temperature ammonia vapor from generator enters into the condenser. As it enters into the condenser, it gives away the heat, thereby temperature decreases. So what is the condition of ammonia after passing through the condenser is the temperature remains, pressure remains same, but it decreases the temperature. So we'll have high pressure, and instead of high temperature, we'll have low temperature liquid ammonia. Here you observe here, we are having the high pressure and high temperature ammonia vapor, when it passes through the condenser, the temperature decreases. So we'll have the high pressure and low temperature. Instead of high pressure, we'll get it as low temperature. Instead of ammonia vapor, we'll get the liquid ammonia. This is the condition of ammonia after passing through the condenser. Okay, our next part is expansion valve. As I said, the function of expansion valve, it performs two functions. First one, it decreases the pressure to practical limits, and the second function is to regulate the flow of refrigerant to the evaporator. Means we have to supply a particular quantity of refrigerant to the evaporator. That function is performed by expansion valve. So what is the condition of ammonia after passing through the condenser is high pressure, low temperature, liquid ammonia. When it enters into the expansion valve, the pressure becomes less, so that it decreases the pressure from high pressure to low pressure. And you remember, there is no change in temperature. That is low temperature only. So the condition of ammonia after passing through the expansion valve is low pressure and low temperature liquid ammonia. So now, so this ends one cycle of operation. For the next cycle of operation, same. The low pressure, low temperature liquid ammonia enters into the evaporator, thereby absorbs the heat. The change in phase takes place from liquid to vapor. So that we'll have the low pressure and low temperature ammonia vapor. It is weak. When it enters into the absorber, which consisting of mixture of ammonia and water, when low pressure and low temperature ammonia vapor enters into the absorber, this solution becomes strong. That strong ammonia solution, which is at low pressure and low temperature condition only, enters into the pump. The main function of the pump is to increase the pressure, so that, and then it enters into the heat exchanger. As it enters into the heat exchanger, the temperature increases and also the pressure increases by pump. So we'll have high pressure and high temperature strong ammonia solution. Here we are having weak solution. That enters into the generator, where the heat is supplied externally. So that when heat is supplied externally, the ammonia floats on the surface of the cabinet, and the remaining water phase enters into the absorber for next cycle of operation. So that this strong ammonia solution, that is which is at high temperature and high pressure, enters into the condenser. So that as it enters into the condenser, the change of phase takes place. So the temperature drops from higher temperature to lower temperature. So that, and next it enters into the expansion valve, where the pressure decreases. Instead of high pressure, we'll get the low pressure. So like that, the cycle repeats. You remember, in case of VCR, we are having only refrigerant. In case of VAR, that is vapor absorption, we are having both refrigerant and absorbent. Refrigerant is ammonia, which is easily soluble in water. That's why water is your absorbent. Another example is water is refrigerant and lithium bromide is your absorbent. These are the two examples, but most commonly used is ammonia and water combination in the most of the cases. Okay, now most important, I'll discuss what are the differences between VAR, that is vapor absorbent refrigeration system, and vapor compression refrigeration system. Okay, First difference is in case of VAR, vapor absorption refrigeration system, it utilizes the heat energy. As I said, generator is there in case of VAR, but there is no generator in case of VCR because we are having a part called as compressor. Hence, the VAR works on heat energy, whereas VCR, vapor compression, works on mechanical energy. Mechanical energy means we are having compressor. Compressor does not exist in VAR. So that rather it utilizes the heat energy. As I said, we are having generator. Generator does not exist in VCR. So first difference is VAR works on heat energy, whereas VCR works on your mechanical energy. Second difference is that it does not depend upon the electric power. Why it does not depend upon the electric power means we are having the generator. We are going to supply the heat externally to the generator, but it needs the electric power. You remember, we are having the compressor. In order to drive the compressor, we require electric power. Hence, VCR requires electric power to run, whereas the electric power does not require in VR because we are having generator where we are going to supply the heat externally to the generator or combustion chamber. Okay, this is the second difference. Third difference is we are going to circulate the required quantity of refrigerant in case of VAR. So how much the energy required to run the pump is less. Comparing to pump and compressor, the compressor requires more energy, whereas pump requires less energy. That is the concept behind pump and compressor. Because of the existence of the pump in case of vapor absorption refrigeration system, so that it requires less energy, whereas the vapor compression refrigeration system requires more energy because we need more power to compress the working fluid. The main function of compressor is to increase the pressure, whereas pump is also same, means it increases the pressure. And third one is we are going to use only particular refrigerant in case of VAR because we are using a refrigerant and absorbent like ammonia and water, whereas water and lithium bromide in case of VAR. So such condition is not applicable for VCR. We can use any type of refrigerant in case of VCR. Any type means we can use ammonia, we can use sulfur dioxide, so we can use freon. I'll explain the different types of refrigerant in the next class. Okay, so that specific refrigerants are used in VAR. No such restriction is there for VCR. Okay, next, fifth difference is, as I said, in case of vapor absorption refrigeration system, vapor refrigerant is absorbed and heated, whereas absorber does not there in case of VCR. Then instead of absorption, we are having compression. Compression is not there in your VAR. So the vapor refrigerant is absorbed and which is heated in the heat exchanger, whereas we don't have heat exchanger. So instead of absorption, we are having compression. Vapor refrigerant is just compressed in case of VCR. Okay. And sixth difference is that, and as we are having compressor in case of VCR, so that it makes lot of noise because of the moving parts of VCR. So noise does not exist in case of VR because we don't have compressor. So it is not noisy because of no moving parts of compressor in case of VAR. Okay, absence of moving parts makes the system so that the system works very smoothly in case of vapor absorption refrigeration system. So because of the moving parts, that is compressor, so that system is more noisy, means the system is not so smooth in case of vapor compression refrigeration system. Then next comes the seventh difference is that, so when you are having compressor, the maintenance cost is more. You see, maintenance cost is more due to moving parts in case of compressor. Whenever we are having compressor, it requires more maintenance because lot of moving parts exist in case of compressor. Because of the no moving parts in case of VAR, we are having pump. So the maintenance cost is less. You remember, no moving parts in VAR, whereas moving parts in case of VCR. So that the maintenance cost is very less in case of VAR, whereas maintenance cost is high in case of VCR. Okay. And one more thing, in terms of capacity, okay, so maximum capacity is 1000 tons. So we can produce the less capacity in case of VCR because maintenance cost is more, there are more moving parts, more noise, more vibration. Because of that one, the capacity in case of VCR is limited to 1000 tons, whereas we can have the higher capacity in case of 1000 tons, that is more than 1000 tons, because we don't have moving parts, so, and operation is quite smooth. Because of that, it develops more capacity, that is above 1000 tons. Okay. Next, at reduced loads, the system is almost same as efficient as full load. Okay. So as I said, the load is required more in case of VCR because of the compressor. It requires more power. As the power increases, then load is also required high. Because of the increase in the load, the COP, as I discussed in the previous class, COP is coefficient of performance. It is defined as coefficient of performance. It is defined as the amount of heat absorbed to the work done. So how much capacity is going to express in terms of COP. COP means coefficient of performance. It is a ratio of Q by W. Q is the amount of heat absorbed from the system to the work done in the system. So, and one more thing, at this one, it requires more load. Because of the high load, the system COP decreases. Whereas we require less load because we don't have compressor in case of VAR. Hence, the system is quite smooth. So it gives the more capacity. We require smaller energy to run the pump, whereas we require more power to run the compressor. So capacity is high in case of VAR, capacity is less in case of VCR. Okay. Next, we are having no chance of refrigerant leakage, and here chances are there because of the wear and tear of the compressor. The chances of leakage of refrigerants are more in case of VCR, whereas chances of refrigerant leakage are very less in case of VAR. Because of more refrigerant leakage, so we'll get the less efficiency. We are not telling efficiency, rather we are calling it as coefficient of performance. So here no chance at all because no compressor, hence you will get the higher coefficient of performance in case of VAR. Next, regarding the application, the VAR are mainly used in the industrial purpose. So because it utilizes the plenty of waste heat is available from the exhaust gases that we can use in case of VAR. You remember the VAR is mainly useful in industrial application, whereas VCR is used for domestic like our normal fridge, air conditioning, commercial as well as industrial application. So these are the main differences between VCR and VAR. So you should have just I'll discuss the application of application of uh, okay. Next, I'll discuss with some refrigerants. Okay, so refrigerants. What are the refrigerants? As I said, refrigerant is a chemical substance that absorbs the heat from the cabinet in the evaporator. Then that gives away the heat to the condenser. So that is a function of refrigerant. It is a carrier substance used in the refrigeration system. And in order to select, we should have the proper properties of the refrigerant. Means it should have the low boiling point. Means we should have low boiling point. It should have low freezing point and high latent heat of evaporation and high critical temperature. Means in order to select a proper refrigerant, we should have the desirable properties. These are the most important properties. Remember, for low boiling point, it should be low boiling point. Then only you'll get the more COP. Low freezing point means it should not solidify under a specified pressure. And it should have high latent heat. Means it should have high capacity to convert a liquid to vapor. High critical temperature means it has to work under all temperature. Next is our physical properties. Means we should have the low viscosity. Means it should not be too thick. It has to flow easily inside the circuit. We should have low viscosity. We should have low specific heat. We should have low specific volume. Means it has to occupy less space. And we should have high thermal conductivity. Means it has to conduct high heat transfer in the system. We should have low viscosity. We should have low liquid specific heat. We should have low specific volume. We should have high thermal conductivity and high electrical insulation. These are physical properties. Next, we are having chemical properties. Means we should have, it should be non-toxic in nature. It should not be toxic. It should not be flammable, and it should not also